We're going on a eutrophication exploration. What's going on, my environmental science friends? Today, we are going to be exploring a little bit around my house, and you're gonna come along with me to look at the different aquatic environments, and we're gonna look for evidence of eutrophication and algal blooms. So essentially, eutrophication occurs when there's an excess of nutrients that are in an aquatic environment. And this can cause, like I said, extreme algal blooming. So the kind of nutrients I'm talking about here are your nitrogen and your phosphorus, stuff you hear about that's in fertilizers used a lot in agriculture. So if these are too present in aquatic environments, that is what can cause the algal blooming. And it is harmful for the aquatic environments because it can cause hypoxia, which basically means no oxygen. And that's not good for any of the aquatic life that is in that environment. In addition to just hypoxia overall, there can be other effects on the aquatic environment, such as higher temperatures and lower pHs, so acidic environments, which is never good for any of the living things that are in that ecosystem. And eutrophication can occur naturally and sometimes does in aquatic environments, but it is heavily expedited and increased when there is things such as agricultural runoff that affect it. So if there is a lot of agricultural runoff, such as that from fertilizers that have a lot of that nitrogen and phosphorus in it, and that's going directly into an aquatic environment like a lake or stream, that's when you're gonna see really heavy presence of algal blooms. So now that I've got all the boring talk out of the way and you have a little bit of a refresh about eutrophication, let's go hunting for some algae. So the first place we're gonna go check is just down by the lake and where the spillway is. And then I'm going to go further down the road after this and look at a different point of access of the lake to see if along that edge there is any more concentration of algae. But first of all, let's check down here. We're almost there. So it has rained a lot recently, which might affect how much algae we actually see. But as you can tell, it is pretty full, and the spillway over there is really loud because there's a lot of water, and it's even flooded down there. So this should be interesting. So along that stretch, it actually looked pretty clear, and that can tell us a number of things. First of all, it is not super sunny, or it hasn't been super sunny recently, so any photosynthetic algae that might be there might not be thriving particularly now, especially because it has been so dark out with the weather. Also, I know that my grandparents live right up this hill. They don't use a lot of fertilizers, pesticides, any kind of chemical things like that, so there's not going to be a lot running off from this incline specifically, so that might mean that there's not as much algae blooming, and that is a great sign. Okay, so now that we have checked that point, we're gonna go further down where there's a little underground stream that runs down a hill, and there will be a couple other points that I can check that might have some algae. So there's some from that stream, and then there also might be some at different points of access for the same lake. So let's go check those out. These other points also could be interesting because instead of being downhill from myself and my grandparents, it is going to be from my neighbors. So I'm not as familiar with any practices they might use on their land, so that might be an indicator. So this is the path that leads down to other points of entry for the lake, but what's really interesting is right here is an underground spring where you can see the water is coming out, and it goes all the way down this hill, and you can already see that there's some algae blooming. So this is the most algae we've seen so far. So here is some algae for you. It kind of keeps going, but this is the most concentrated area I've seen so far. So that's pretty cool. So the stream runs all the way down. And as you can see, there's not too much algae. It seems like the most that we saw was up there at the start of the spring. And here is the other side of the lake. So I'm looking around the edge of this entry point for the lake, and I'm still not seeing too much algae. The most I've seen so far has been in that little stream from the underground spring. But it's really interesting to see how there is some presence of that in the spring, but I'm not seeing too much at the lake. And there's a lot of reasons why that could be. So you guys should brainstorm and see what you guys come up with for why that might be. This would be a really fun exploration and kind of lookout to repeat in the spring or summer, considering that these photosynthetic algae and all this stuff could be happening more frequently, or there might be higher concentrations of algal blooms in the summer where there's sun more often and warmer conditions. Even though we didn't find too much algae, this is a good indicator that our lake ecosystem is functioning properly and we are at no risk for hypoxia or any killing off of any aquatic species because we have too much algal blooming. So I hope you guys enjoyed our little eutrophication scavenger hunt. It didn't really pan out to be all that much eutrophication, which was a good thing in actuality because that can cause a lot of hypoxia and the killing off of aquatic organisms. So that's pretty good that we don't have too many algal blooms. I do think that there would have been a lot more if there had been sunny weather more consecutively in the past, and if it was a different season when these algal blooms are more likely to be thriving. So it would be interesting to revisit at a later date, so maybe I will do that. But thanks for tagging along with me. I hope this kind of helped you learn a little bit about eutrophication, even though we didn't see too many examples. But keep exploring, keep being awesome environmental scientists, and I'll talk to y'all later.